Well, good morning, everyone, and welcome here to the launch pad. You are looking at a live view of Launch Complex 39B at NASA Kennedy Space Center as we count down just over 8 hours until NASA performs one of two countdowns for today's wet dress rehearsal of the Artemis 1 SLS rocket. Now, if you've been around for a little while, you know this is not the first wet dress rehearsal attempt NASA has conducted. This is actually the fourth that they've conducted, but the first since SLS was rolled back to the VAB for repairs and some maintenance before it rolled out about 2 weeks ago back to the pad. And here we are again, ready to conduct another wet dress rehearsal. At this time, the launch director, mission management teams are meeting and having a weather briefing as well as tank briefing to begin to be prepared for that launch director to conduct a go-no-go poll at L-7 hours, 50 minutes and counting on whether or not they will begin tanking operations on schedule. Now, one thing we're really excited about this time is that NASA will be providing more communications throughout today's wet dress rehearsal, including live comms during it, and those comms are expected to get underway in about 30 minutes, and we will, of course, patch those in so we are able to hear them throughout today's wet dress rehearsal to stay up to date on everything that is happening at Launch Complex 39B. As always, if you guys have questions, you can send those in the chat, and we'll be answering those live throughout today's broadcast. We'll be staying on the air throughout today's entire wet dress rehearsal, bringing you updates on screen, updating those countdown timers throughout the steps that go. Now, first off, right off the bat, we're going to have one main question is, why will there be an L- and a T- clock? Right now, you see two L- clocks, but soon you will see a T- clock appear on your screen. Well, that's because there are actually two countdowns operating right now for kind of two reasons. One, NASA is going to conduct two wet dress rehearsals, so we might add a clock to count down to the second test to later today. They're going to count down all the way down to about T-minus 30 seconds. Then they're going to hold, recycle back to T-minus 10 minutes. Takes about an hour to do that, and then they're going to count down through again. So we're going to see two wet dress rehearsals today. But why T-minus and L-minus? L- is real-world time until the test is conducted. If there's holds built in or anything, all that time is built in. So 8 hours, 13 minutes from now, that is when we are expecting basically T0 of the first test. Once we introduce the T- clock, the T- clock is including holds, but that clock can pause. So right now we're at L- 8 hours and 12 minutes, but we're actually only at T- a couple of hours because there are built-in holds that happen throughout today's countdown. So once we put those up on the screen, we'll explain them a little bit more, but that's something we're going to have to get used to again with SLS. We saw this with Space Shuttle, that we'll have to get used to those two countdowns. So here in the Launchpad, we're going to generally use L- because that's the real world time. So you guys can have an idea on when you need to come back if you have to head out from what is actually happening. As we get started, though, let us know in the chat where you are watching from. We know people are tuning in from all over the world, and it's great to have you all here. But launch teams are all on station. The weather's looking not too bad. There's a bit of weather off the coast, but the teams are conducting their weather briefing right now, and we should hear an update from them shortly on whether they're going to conduct that go-no-go poll and begin tanking operations on time. Now, they are targeting very similarly to what we saw last time, about a 2 to 2:40 p.m. window. The first wet dress rehearsal is targeting 2:40 p.m. And then about 3:45 to 4 o'clock Eastern, they are targeting that second wet dress rehearsal after they do the recycle. So if everything goes well, it's going to be a bit of a longer day, so grab some drinks, grab some food, and join us in the chat. If you haven't yet, though, and you want to follow along with updates, you can do so over on our Twitter. We'll be live tweeting updates on there as well, and join us on the Discord when I'm not doing commentary updates live here on air and we're researching what's going on and getting updates from NASA. we're going to be hanging out in live comms on our Discord. It's free. You're welcome to join, and we'd love to hear your guys' opinions on how you think today's wet dress rehearsal will go, and you can do that on the Discord, but also in today's poll. How do you think it's going to go? Obviously, we do hope it goes well. We want to see this wet dress rehearsal checked off the box so we can see Artemis 1 launch sooner than later. Do you think it's going to go perfectly with the wet dress rehearsal be completed? Do you think there's going to be a scrub, maybe due to weather? Do you think it's going to technically be a fail due to a rocket issue or a fail due to a ground support issue? We saw technically all ground support issues with one exception of a rocket issue on the first 3 attempts, and weather generally wasn't a major issue once they actually got this far into the count. But we want to hear what you guys think in there. Before we take a quick pause in our commentary break and get ready to patch NASA in with their live updates, we will invite you to take a moment, share out the broadcast, and engage that like button. It really does help us out to let YouTube know that you like what we're doing, and help us get this out to the world as we count down to NASA's 4th wet dress rehearsal of their next generation mega moon rocket that will soon return humanity to the moon. And just in a few years, we're going to see humans board that next rocket that looks just like that from this pad and go back to the moon, which is pretty exciting. As always, if you guys have questions, you can send those in the chat by tagging us at the launch pad. That helps flag us there. And if you like what we do, consider heading on over to our Patreon. It really does help us out to have people on site for events like this, but also to start covering other launch sites around the world to bring you the best possible space coverage of everything space. Because here at the launch pad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. But stay with us. This is a live view of Launch Complex 39B at NASA Kennedy Space Center as we await NASA's update on whether they are go to begin fuel tanking operations. Stay with us. Well, again, good morning, everyone, and welcome here to the launch pad. You are looking at a very bright view of Launch Complex 39B at NASA Kennedy Space Center as we count down T-minus 7 hours, 54 minutes, and counting until the first of two wet dress rehearsal T-zeros that NASA is targeting here today. Launch director and mission teams are continuing to conduct a weather and fuel tanking briefing at this time. We are expecting to hear a go, no go from them in the next few minutes. That poll expected to take place at L-minus 7 hours, 50 minutes. And we hope to hear some updates from them shortly after on whether they will continue through into the beginning of the tanking operations. Tanking takes quite a while, but as you can see, we've updated our countdown clocks. The L- and H- clocks are on screen right now. The H- clock is the clock that will be counting down as similar to a T- clock, but whenever we are in a built-in hold, it will say H-, so you know that we are in a hold on that official clock at that time. These clocks are matched to the ones from NASA, so within a couple seconds there, so we are counting down from both of those. But real world time, look at that L- clock. That is how long we are targeting for it. We are keeping an eye on the weather as well. Things looking seemingly good on the KSC weather system. A little bit of rain off the shore to the east, but it looks like it's going to be staying off the coast right now. Probability of sustained winds that are quite high seem quite low, less than 30%. We are keeping a close eye on kind of all those weather conditions as we go through today's countdown. Now, there is a probability of some rain here today, up to 40%. But the temperature is looking good and everything else quite low for risk. So those are good signs that today's wet dress rehearsal will be able to continue. In about 10 to 15 minutes, we are expecting NASA to begin their live updates as well. We don't know what to expect from these updates, but we will, of course, patch those in so you guys will be able to hear updates from them as things happen. And we, of course, will give our own updates throughout today's countdown as well. If you guys have questions, though, you can send those in the chat by tagging us at the Launchpad. It really does help us out to see those questions and be able to answer them. We'll be answering them live in the chat, but also on screen, or on commentary, excuse me, as we go throughout today's countdown. But if you're just joining us, you are looking at a live view of Launch Complex 39-B, 39B at NASA Kennedy Space Center as we count down through one of two wet dress rehearsal runs that NASA will be conducting here today. The targeted time, 2:40 p.m. Eastern Time for the first wet dress rehearsal run, if everything proceeds nominally through today's countdown. Now, they can hold. This is not a launch. So what you're going to be seeing here today is that they're going to run through everything all the way down to T-minus 33 seconds, and then they're going to hold. They're going to recycle back to the T-minus 10-minute mark. That takes about an hour to recycle to. Then they're going to resume the countdown and go all the way down at T-minus 9.34 seconds. Hold and scrub, and then they will go through fuel draining operations. Now, this may be the first time we ever see an SLS fully fueled, all the stages ready to go. We'll see some venting. That's why we have our close-up shot at the base of the SLS. That's where we will hope to see some venting occur. Now, there are flame diverters that have been put into place. That is part of the mobile landing pad, mobile transport, that are there. That's those bigger metal parts under the rocket, right under the main platform. So those do hide a lot of the venting, but last time we did see some venting there, so we'll adjust that close-up shot as we can throughout today's wet dress rehearsal to bring you a little bit of a close-up on there. Now, this camera is provided by NASA to media to be able to use. No one is allowed out at the pad, but we do have our team following along with everything, making sure we bring you timely updates on everything that has occurred. But at this time, L-50, we are expecting that the team should be conducting their final go, no go for everything today on if they are going to begin their fueling operations. There's lots more go no go polls throughout the day, but this is the main one. Do we begin fueling operations in the next little bit? And NASA just tweeted from their team, starting today at 7 a.m. they will begin their broadcast to follow along today's wet dress rehearsal. So we will plan on patching that in here in about 10 minutes time. But if you're just joining us, take a moment, engage that like button. It really does help us out, and share out the broadcast as we count down through today's wet dress rehearsal of the Artemis 1 rocket. Stay with us right here on the launch pad.
Good morning and welcome to NASA's Kennedy Space Center in Florida for the second day in the final test of NASA's mega moon rocket that you see there on your screen, the Space Launch System. Good morning, everyone. I'm Daryl Nail with NASA Communications here at the Kennedy Space Center in Florida, and I'll be your commentator for the duration of today's wet dress rehearsal. This test is wet because it involves the tanking of liquid propellants into the rocket. During rehearsal, the launch team is practicing every phase of the countdown, including weather briefings, pre-planned holds in the countdown, conditioning and replenishing the propellants as needed, and validation checks. This will give their engineers their final opportunity to test the Space Launch System rocket, Orion spacecraft, and exploration ground systems before Artemis 1 launches from here at Launch Pad 39B on a test flight around the moon. I'm currently sitting with the launch team inside firing room 1 of the Launch Control Center, which is more than 3 miles from that view that you see there on your screen. And as you can see, we are going to be counting down today. We have a countdown clock that we'll be using to count down to allow you to track the amount of time left in the operation. We are currently T-minus 6 hours, 40 minutes, and holding until a simulated T0. We will not launch today. This is just a wet dress rehearsal. The Artemis 1 launch team began preparations for today's cryogenic tanking of more than 700,000 gallons of super chilled propellants with a call to stations on Saturday night at 5 p.m. That's when the countdown clock began. It was T-minus 43 hours at the time. And now we're down to T-minus 6 hours and 40 minutes, as you can see from the countdown clock on the upper left-hand portion of your screen. We do have 2 pre-planned holds in this countdown. We are in the first one right now. That should end here in just a few minutes. The second one is at T-minus 10 minutes, and that one lasts a half an hour. Now, leading up to this current hold, there's been a lot of work. Kennedy's Exploration Ground Systems team has activated the facilities needed here for launch at the Kennedy Space Center. Launch controllers have powered on different rocket and spacecraft systems along with ground support equipment. The launch team here is connected with staff at other centers as well. We have team members in the Mission Control Center at NASA's Johnson Space Center in Houston. We have folks at the Space Force's Eastern Range and the SLS Engineering Support Center at the agency's Marshall Space Flight Center in beautiful Huntsville, Alabama. Here's the plan for today's wet dress rehearsal. Today's simulated T0 is at 2:40 p.m. Eastern Time, but for wet dress, launch controllers have a pre-planned cutoff at T-minus 33 seconds. They will then demonstrate the ability to recycle the countdown clock back to T-minus 10 minutes, which should take about an hour, could be more. That's one of the things they're working in this wet dress rehearsal and want to find out exactly how much time it takes. And then they'll conduct the terminal countdown again, this time with a pre-planned cutoff at T-minus 9 seconds. After that, the launch team will then drain the tanks to give them an opportunity to practice the timelines and procedures that they will use on launch day. Let's talk a little bit about what you will see in today's coverage. As you can see, this is our big wide shot of the rocket on the pad there. You see the 3 lightning towers, Space Launch System on the mobile launcher at pad 39B. This is the wide view of the rocket and the launch pad. It is looking west away from the coast, and it gives us a profile of the rocket with one of its 2 solid rocket boosters that you see there on the side with a NASA worm in the middle of it. We will alternate from time to time with this view. That is an engineering camera that you're looking at right there. It's mounted to the mobile launch tower booster nozzles to the south. It's mounted to the mobile launch tower looking to the south. So after we get into tanking, you'll be able to see liquid oxygen turning to gas during the liquid oxygen engine bleed. The other propellant, liquid hydrogen, will also be bled through the engines in order to condition them down to the cryogenic temperatures needed before lighting them up for launch. We've got a sunrise here, and so you can tell on the left-hand side, the sun shining, giving us a good view of those RS-25 engines in the middle, and to either side, those solid rocket boosters, the aft skirts with the checkerboards on them, and then below are the nozzles. Let's go back out to the wide shot, where we will also be showing a new real-time data-driven graphic. We want to keep you apprised of the cryogenic tanking process and the progress of the world's largest booster, the SLS core stage. Here's our graphic here. You can see the lines show us the height of the rocket, 322 feet tall, taller than the Statue of Liberty in New York City. You can see the mobile launch tower stretches up to 345 feet tall. And the total height from the bottom of the pad to the top of the ML is 370 feet. Across the bottom of your screen, we have a progress bar that will track how we're doing across the timeline with the major milestones towards tanking. And we also have a series of gauges that will track the propellant fill in the liquid oxygen tank, which is in the upper portion of the booster, as well as the hydrogen tank, 538,000 gallons of liquid hydrogen in the lower portion of the rocket. You can see the two tanks in this graphic. In the lower portion, the larger tank, that's the hydrogen. The upper tank is the liquid oxygen tank. And this graphic, they will fill as we move along. Just one note, we do not have a graphic for the tanking of the upper stage today, the ICPS, but the team is working on it, and the hope is to have it ready before launch. And of course, a special shout out to the Orion communications team at the Johnson Space Center for building this graphic for our broadcast today. All right, before we get started with commentary for today's operation, I want to let you know what to expect. We are going to cycle these shots as you see here. This will be the primary shot of the pad and the rocket for the duration of the 8 to 12 hour broadcast. I'll be listening to the launch team communicate and will provide commentary at the following times. I'll give a summary of the overall tanking operation at the top of every hour. At the half-hour mark, you'll hear updates on the current status of the countdown and cryogenic tanking. And I'll also break in to let you know when any key milestones have been reached. I'll also speak to any pauses in the countdown clock or any major issues the launch team is working that could affect countdown. Lastly, we are planning on several interviews. One of them with the woman leading today's wet dress rehearsal, and that's Launch Director Charlie Blackwell Thompson. We also may hear from senior members of her launch team. And as I mentioned at the top of the show, completion of today's test is a critical milestone for NASA to take its first step towards returning to the moon, but this time in a sustainable way to develop the technologies needed to go on to Mars. To get there, we need to test fly this rocket, the world's most powerful rocket, on a flight around the moon called Artemis 1. I want to show you something really quick before we continue with our commentary. Several days ago, we took a photo that we want to show you. We were out at the pad, our photography team here at the Kennedy Space Center. Took a shot that really struck us. We like this picture because it shows the starting point on the left, Launch Complex 39B at the Kennedy Space Center with the Space Launch System and Orion on the pad, and it was a full moon just a few days ago. And so with the starting point on the left and on the right, the destination, more than 250,000 miles away, our moon. And with that, let's get started. The mission management team and the launch director, Charlie Blackwell Thompson, they met this morning at 6 a.m. And during that meeting, they did get a weather briefing. We are good to go for tanking with regards to the weather. As you can see from this shot, looking pretty clear out to the west. To the east, we have some storms offshore, but our launch weather officer telling us it does not look like those will impact today's operation. One of the concerns with tanking a rocket today for wet dress is lightning. We can't have any lightning strikes within 5 miles of the pad. And so our launch weather officer has given us a less than 10% chance that there will be lightning affecting today's wet dress rehearsal. Probability of precipitation is 20% in the window that we're looking at today, which stretches until 2:40 p.m. this afternoon. It could go later, as previous wet dresses have done. Rain is not a problem for the launch team, but lightning is, particularly when it comes to tanking the liquid hydrogen. And so there has to be a less than 20% chance of rain, or I'm sorry, with less than 20% chance of lightning within 5 miles of the pad before that tanking can begin. So we're keeping an eye on the weather, and so far it looks good. Again, lightning under 10% this morning. Got a high pressure system that gets into place and is starting to push down some weather around us. Doesn't mean that we couldn't have a rogue shower pop into the area, but our launch weather officer will be keeping a close eye on that. The launch team is working a few issues. We'll get into those later, but nothing that prevented them from moving forward with tanking. During the mission management pre-tanking briefing with Charlie Blackwell Thompson and Mike Seraphin, they were given a go for tanking this morning. And with that, I'll step aside for the moment. This is Artemis Launch Control.
And there we go, our first update from NASA in their team. Some interesting updates in there. One, they are go to begin tanking operations, so we are keeping a close eye on that. We did hear there that they are working some issues, but nothing that restricted them from proceeding into today's operations. So hopefully we'll hear some updates on what those exactly are, as that's what we were hoping to hear in the commentary. But if you're just joining us, you're looking at a live view of Launch Complex 39B at NASA Kennedy Space Center, where NASA's next generation Mega Moon rocket is preparing to conduct a wet dress rehearsal. We'll be switching on and off between some of those views that they showed you. Apologies for some of those a little bit more abrupt changes. They introduced some new graphics that they didn't tell the media about, but we're really excited that they've done so. Some great information there. But right now, Orion SLS fully powered up. The pad is clear. The launch director is go about to begin tanking operations. So we will be listening in to see when that occurs. But as always, if you guys have questions, you can send those in the chat by tagging us at the launch pad, and we'll be answering those live throughout today's wet dress rehearsal. As we heard, we're going to get updates every 30 minutes from the NASA team on the commentary. At the top of the hour, a general rundown of everything, and then at the 30-minute marks, other updates. And then they'll break in with any updates as well. So this is really great communication. We'll also be monitoring our channels from the NASA media team and Orion team on how today progresses and bring you our own commentary updates throughout today's count. If you haven't yet known, though, welcome. My name's Zach. I'm the founder and host here at the Launchpad, and here at TLP, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and we're glad to have you all here, people tuning in from all over the world for today's Artemis 1 wet dress rehearsal, as we get ready to usher in a new era with humanity going back to the moon with the Orion spacecraft on top of the Space Launch System from NASA. Counting down T-minus 7 hours, L-minus 7 hours, 23 minutes, 10 seconds and counting. We are remaining in a hold at H-minus 6 hours, 40 minutes. That is planned. We are expecting that countdown to resume here shortly, should everything proceed well. This is a built-in hold, so don't worry there. But for those that are just joining us, why are there two countdown clocks? L-minus and H-minus will sometimes say T-minus. You're used to T-minus with most launches. T-minus is the operational countdown. So there are built-in holds that can occur in that timeline, and when they do, it goes to H-minus, and then it'll go back to T-minus once it resumes the count. L-minus, the easiest way to think of it, is real-world time. In 7 hours and 22 minutes, that is when we expect the wet dress rehearsal initial test T0 to be. Now, we could see delays, and we will update our countdowns as we go through, just like we saw in the earlier attempt. Sometimes they have to reset the clocks throughout the count. This is a test, remember. This rocket has never flown before. This rocket has never been fully fueled before. This rocket has gone through static fire tests where sections of it have been fueled, but never all together in one piece. If they were to reach all the way down to T0 today, this rocket would launch, but we're not going to see that. They're going to roll down all the way to T-minus 30 seconds, hold. They're going to recycle back to the T-minus 10-minute mark and hold there. That takes about an hour to do. Then they're going to resume the countdown and proceed down to T-minus 9.34 seconds, hold and scrub, and then go through tank safing and then tank draining operations. So we're going to see 2 runs through today's wet dress rehearsal if everything proceeds well. As you heard there in that last update, weather is looking good. There's a high pressure system moving in, helping clear out some of the weather. We may see some rain. It's normal in Florida to see these type of things occur throughout the time of the day, throughout this season, but at this time things are proceeding well. We're going to take a quick look. There's a close-up of the base of those engines. You're looking at the side of 2 RS-25s. There's 2 more on the other side, and there you can also see the base of those SRBs, and it looks like there's some fabric wrapping around a few things at the base there, so definitely not in a launch configuration for today, but great to see one of those engineering shots that we wouldn't normally get to see of the base of NASA's Mega Moon rocket. Those RS-25 engines are the same engines that were on the space shuttle, and I don't mean just the model. Those are actually engines off the space shuttle. Every space shuttle had 3 of them, and the first few SLSs will be using the retired space shuttle's engines. They've gone through some upgrades and some updating. Obviously, they haven't flown in over a decade, but those are space shuttle engines being reused by NASA that will then very sadly be thrown into the ocean when this launches and not recovered. But those are space shuttle engines. It's great to see them back out at the pad. And those SRBs, some parts of those are from shuttle era as well. So this is very much shuttle era technology that has been upgraded into a Saturn V style rocket. But this is NASA's next generation Mega Moon rocket. There'll be no crew on board. I've seen that in the chat a few times. No crew on board for Artemis 1. Artemis 1 will be heading to the moon to conduct a test flight flyby of what Artemis 2 will do. Artemis 2 currently expected to launch now in 2024. That will take the first crew back to the lunar orbit, and they will be there for a number of days. Artemis 1 will also be there. Artemis 1 is expected to be in orbit for possibly up to about 24 days, I believe it is now. Depending on the day they launch affects when it will return. So these are going to be longer duration missions than we saw during Apollo. That's the longest it could stay, excuse me. But we will see these missions being longer in orbit and on the surface with up to multiple days on the ground. I believe we saw up to 4 to 7 days is what NASA's targeting for the lunar lander when we take humans back to the moon. Currently now targeting, it was 2024, now 2025. As always, if you guys have questions, you can send those in the chat. We'll be answering those live. Just make sure you tag us at the Launchpad, and take a moment and consider heading over to the pinned link in the comment there, launchpad.store. You can check out our brand new TLP shop where we do have our SLS collection. You can get your Orion capsule schematic tee, your SLS tee. You can get your really detailed SLS schematic, which has the rocket, the capsule, the engine, and everything on there. It's a great way to help support us, but also share your excitement with the people in your community as we count down to going back to the moon. We're going to take a quick commentary break. We've got NASA still patched in, so you'll hear raw updates as those come in, and I'll be back with more updates shortly. But stay with us right here on the Launchpad as we count down through the wet dress rehearsal of Artemis 1 as we prepare to go back to the moon.
This is Artemis Launch Control with an update on wet dress rehearsal. If we were nominally proceeding at this point, we would be looking at starting the cryo tanking in just under 8 minutes, but we do have a pause, a hold. We should say we're currently in a hold at T-minus 6 hours and 40 minutes. That is supposed to last an hour and a half. We're supposed to come out of it in about 8 minutes to start tanking. However, there has been an issue that has come up with the liquid nitrogen, the gaseous nitrogen line. There's a problem with the redundant leg of the GN2 supply. The primary supply is good. It's the backup supply. There's an issue with the controller for the supply valve. And so the launch team is currently working that issue, but until they continue to, until they find a resolution, the launch team has decided to hold off on cryo loading until they have a better understanding of what is required for that repair. And so we will maintain the hold that we are in currently at T-minus 6 hours and 40 minutes. Again, we have an issue with the backup supply for GN2, the gaseous nitrogen. There's a problem with the redundant leg, and the launch team is working it to find resolution. Of course, we'll have more updates as we move along. For now, this is Artemis Launch Control. this is Artemis launch control at T-minus 6 hours and 40 minutes. Currently in an extended hold at the moment as the launch team works an issue with a redundant gaseous nitrogen line. The team currently, again, extending that pre-planned hold. And we heard an update just a few minutes ago to the launch director from the team working the issue. They are repairing a valve that's not operating properly in the gaseous nitrogen line. They reported it will take potentially 90 minutes, maybe less. And the NASA launch director, Charlie Blackwell Thompson, confirmed that and says she wants her team to continue working in parallel. Stand by. Okay, we got some good news. I was listening to an update from the team working the nitrogen problem. They have replaced the valve already, so work is going quicker than expected, but they do have to test it, make sure that it's operating properly. Again, this is a repair to the redundant gaseous nitrogen line that goes out to the pad. NASA launch director Charlie Blackwell Thompson asked her team, though, to continue working on the timeline even though we are currently in an extended hold. She wants to press towards tanking, letting the work on the gaseous nitrogen line continue in parallel as her team works through their processes and configuring for cryogenic tanking. And she asked them for an update in about 45 minutes on that work. Talk a little bit about gaseous nitrogen and why it is so important to tanking and to launch. It is used to inert the vehicle cavities, basically preventing buildup of hazardous gases. It's also used to keep the avionics and electronics in the engine section dry, and it provides some thermal conditioning. And so for those reasons, the GN2, as they call it, gaseous nitrogen, is critical to get started with tanking. Listening to the launch team continue to work the issue. But again, with the gaseous nitrogen, it is a serious condition if the launch team has to switch away from gaseous nitrogen to air in order to clear out these cavities around the rockets, around the rocket where hazardous gas could be building up. And so even though this is the redundant line, they want to make sure they have a primary and a redundant line, and that is currently in work. We'll keep you updated on the progress. In the meantime, we are currently in a hold, an extended hold at T-minus 6 hours and 40 minutes. This is Artemis Launch Control.
And if you're just joining us, welcome here to the launch pad. You're looking at a live view of the engineering cam at Launch Complex 39B at NASA Kennedy Space Center, where we have entered an unplanned extended hold prior to beginning of fueling operations of the NASA SLS Artemis 1 rocket. There you can see on your screen, teams were given a go by weather and by everyone to begin fueling operations. The last go needed to be given by the launch director, and they were going through their polling, and they discovered an issue with the GN2, the gaseous nitrogen, which is used to help purge the system and make sure fires can't happen when there is hydrogen present. So super required to have prior to the loading of the propellant onto the SLS rocket. At first we heard that it was going to take about 90 minutes to change out the valve and test it, and while they were giving that update, teams had already replaced the valve, so now they are going through some testing to make sure that valve is operational. This is not the primary supply, this is the backup supply, so it's not as concerning of an issue, but it's still an issue that has arisen that has to be fixed, because if something were to go down with the primary, they need to make sure they have their backup in operations. So again, looking at older hardware, this is a lot of shuttle era, a lot of stuff that hasn't been used in a while, and it's going through its testing. This is, if I'm correct, the third out of the 4 wet dress rehearsals that have had some sort of GN2 supply issue, valve issue, during all of these wet dress rehearsals. They supposedly had upgraded the system during this break. That's why they rolled it back, was that the supplier was going to make upgrades to the system, but I guess they didn't upgrade this valve, as we are now in an extended hold. Fueling operations have not begun. They are on hold, but SLS and Orion remain powered up on pad 39B, and they are expecting it to be about a 30 to 45 minute delay. Right now we still have our L- clock running, as Charlie Blackwell Thompson has instructed her team to continue their operations running alongside as the team is working issues. There are other things that they can be working on in the timeline as they proceed, but that L- clock will have to be reset, and we are still holding at that 6-hour 40-minute mark in the T- clock as we await for them to be able to exit this hole. But a 30 to 45 minute delay kicking off today's 4th wet dress rehearsal of the Artemis 1 rocket. Really oh, they're panning the engineering camp. Let's see what we're going to look at. We're now looking at the side of the rocket. I guess they're just going to give us a nice view of SLS. Maybe they forget that this camera is live. We'll wait and see, but we'll take all the views we can get this close up of the Artemis 1 rocket. This is just a taste of some of the views we're going to get during the actual launch sequence from NASA, so it's great to be able to get some of these views here this morning. As always, if you guys have questions, you can send those in the chat. We'll be answering them live throughout. It looks like they noticed throughout today. Make sure you tag us at the Launchpad. But also follow us over on our Twitter. We've been live tweeting updates as they've been happening, with some explanations on things as well. You can follow us over on Twitter at TLPN_official. Or join us over on Discord. We do have a thread running where we're sharing live updates as well. While they're giving updates on air, we're getting that information out to you in other ways. So at this time, the first issue of today is with a faulty GN2 valve for the backup gaseous nitrogen supply. Needed to be operational prior to fueling operations being able to begin. But right now, weather's looking good. The rocket's technically good. It is right at this time a ground support issue, which comes to our poll of today. We want to hear from you. Oh, they turned the camera back on. There's the top of the rocket. We want to hear from you guys. How do you think today's wet dress rehearsal will go? Do you think it's going to be a perfect wet dress rehearsal? Do you think there'll be a scrub due to weather, a fail due to a rocket issue, or a failure due to a ground support issue? We want to hear from you. What do you think will be the big part of today? What are they zooming? I think they keep forgetting that camera is publicly viewing at times, because they're zooming in on something on there, which is quite interesting to see. So we're going to keep it on that camera just to see what else we maybe get to see if it's in an automated loop. at this time. This is new for everyone. This is the first time we are having live coverage from NASA of the wet dress rehearsal, other than just a raw camera and tweet updates. We are getting commentary updates. But at this time, the test isn't done for today. We still have time on the clock. They are still able to recover this. They won't want to move fueling operations into the evening too late, but we can see at least 3 or 4 hours of delay throughout today's events and still be able to conduct a successful wet dress rehearsal. But we may still see, you have to question, what are those issues, and are they going to be issues when we go for launch? But that's why you test. You test to iron out all the kinks, and that's what NASA is doing here today. But don't forget, take a moment, engage that like button, and share out the broadcast as we count down through the 4th wet dress rehearsal of the Artemis 1 moon rocket as we prepare to go back to the moon. Stay with us right here on the launch pad.
Good morning. It's 8 a.m. here at the Kennedy Space Center in Florida. We are at the top of the hour, currently in a T-minus 6 hour and 40-minute hold. The hold has been extended due to a problem with a gaseous nitrogen valve. It was a failure of the controller, according to the launch team, for the valve on the backup leg for gaseous nitrogen that goes out to the pad that you see there with our SLS rocket and Orion spacecraft. That failure is that it would not close. Not sure about what caused the failure at this time, but the teams have been working on it and have replaced the valve, and a manual retest of that valve is working well, according to the team that's out there. It opened up all the way. They checked it at 50%, worked well. And now they're focused on the controller, which will give them automatic control of this valve. They have an automated test that they are getting ready to conduct to see if that works properly. They want to be able to set it to primary and adjust the flow. That's going to be part of the test. Moving forward, they advise the launch director that once they get it completely checked out, if everything goes as planned, they will want to run the gaseous nitrogen on the questionable leg as the primary and put the good valve as the backup. Engineers say it's good logic to them. The issue is not with the actual valve itself, but with the controller. So they're continuing to work on that issue and test the controller for the valve. In the meantime, we are in that extended hold until that is resolved. The launch team, meanwhile, has been moving forward, configuring the launch vehicle for tanking. They have cycled the valves for liquid hydrogen in the upper stage, and then began proceeding with cycling the valves on the liquid oxygen stage. Rather, the liquid oxygen tank in the upper stage. Again, gaseous nitrogen is important to today's wet dress rehearsal because it's used to inert the various spaces in and around the vehicle and the rocket, prevents the buildup of hazardous gases in case there's a leak, and also keeps the avionics, the computers, the electronics in the engine section dry. So if they don't have good GN2, which they do, this is the backup leg, but they want to have full confidence that if one line goes down, they can go to a backup. Giving you an overview of the start of today, we did begin the day with a mission management tanking pre-briefing. Charlie Blackwell-Thompson gave her team the go prior to this issue coming up. We got a weather update. Weather looks good for tanking. Only constraint, 10% chance of lightning in the area during the tanking of liquid hydrogen. But that's not an issue to prevent them from moving forward with tanking. We're providing updates on the hour and the half hour here on NASA Media Channel. We'll have more updates to come as we go along. Again, I mentioned the team working in parallel to begin preparing for cryogenic tanking while they await an update on the test of that controller to a gaseous nitrogen backup valve. Stay tuned for more updates. For now, this is Artemis Launch Control. This is Artemis Launch Control. Good morning. It's 8:30 a.m. Eastern Time here at the Kennedy Space Center in Florida, where we are currently in an extended hold, awaiting the resumption of the countdown to cryogenic tanking of the Space Launch System, the rocket that you see on your screen. So we had a constraint to launch there, to tanking, that was lifted. The constraint to beginning the cryogenic tanking of the Space Launch System rocket was lifted after an issue arose with the controller for a valve on the backup leg for gaseous nitrogen that runs out to the pad. The location of the valves is at a Kennedy facility called the CCF, or Converter Compressor Facility. You can think of it as a hub for the two nitrogen lines about a mile or more from the pad. Those two lines, a primary and a backup, come from the supplier of gaseous nitrogen. The GN2 team reported an issue with the controller. They have conducted manual testing, which has worked, and they have worked the automatic testing as well, and that has tested out good. And so the pressures for both lines are good. The team reports confidence in the redundant system, which is actually now the primary system. They've got the primary now on backup, so there was a swap there. And now they are ready to proceed into tanking. This did create a delay, and so chill down for cryogenic tanking is now set to begin at 9:05 a.m. Eastern Time, which is in just about 33 minutes. We will plan to come out of the hold that we are currently in at 9:20 a.m. Eastern Time. That should put us at a simulated T0 of roughly 4:30 p.m. Eastern Time. The launch director asked for a weather update with the new time. The LWO, the launch weather officer, reporting that we do have a few showers offshore. They are dissipating. Some showers could develop around the pad in the early afternoon, but they're expected to move west. Tanking, therefore, and the weather forecast for tanking is go. Now, since the issue with the nitrogen, the launch team had continued to work through that and is continuing to configure the vehicle for tanking, checking off their milestones and moving forward. Again, looking to come out of the hold at 9:20 a.m. Eastern Time after an issue with the backup nitrogen line was resolved. The GN2, gaseous nitrogen, which goes out to the pad, is used to help inert the various vehicle cavities and prevent buildup of hazardous gases. It must be present in order to do tanking because should there be a leak, the nitrogen is used to clear out any buildup of gases in areas around the rocket. That's our 8:30 update. For now, I'm Daryl Nail with NASA Communications, and this is Artemis Launch Control.
And if you're just joining us, good morning and welcome here to the launch pad. You're looking at a live view of Launch Complex 39B at NASA Kennedy Space Center, as teams have confirmed that they have repaired the GN2 valve issue and actually swapped the primary and secondary backup system. So the primary is now backup and the secondary is now the main system, as they know it's working, and they are getting ready to resume the countdown here in the next few minutes. We're going to be updating our T0 and our L- clocks. We are still holding at H-6 hours 40 minutes. That countdown expected to resume in about 30 minutes time. That L- clock will be updated here in the next couple of minutes as we confirm that new estimated T0 of the first run of today's wet dress rehearsal operations. Had a little bit of a glitch there in the stream, so apologize there for that with the feed. NASA shutting down one of the feeds that they were giving media. So we hope to be able to patch that back in here shortly, but at this time we still have at least their main feed available. If this is your first time here, don't forget, engage that subscribe button. It really does help us out, and share out the broadcast. We'll be staying live throughout today's wet dress rehearsal operations, as well as staying live throughout any continued operations should we not be able to complete the wet dress rehearsal here today. Here at the Launchpad, we cover everything space, launches, landings, space dockings, undockings, exclusive one-on-one interviews, and more. We have some interviews with the Artemis 1 team coming out here very shortly, so make sure you subscribe so you see those for some exclusive interviews. But if you guys have questions, you can send those in the chat by tagging us at the Launchpad, and we will be continuing our live coverage. So stay with us right here on the Launchpad as we continue counting down towards the wet dress rehearsal estimated T0.
This is Artemis launch control at T-minus 6 hours, 40 minutes and holding. I'm Daryl Nail with NASA Communications with an update here on the countdown as well as cryogenic tanking. The launch director just gave the go for cryogenic tanking to the Space Launch System just a few minutes ago. A major milestone achieved this morning after a little bit of a delay and a few issues. Joining me now is Jeremy Graber, the Assistant Launch Director to the Artemis team. Appreciate you being here, Jeremy.
Thanks, Daryl. It's great to be here.
And so, been a lot of activity so far this morning. You've been at the center of it. Tell me a little bit about, first of all, the issue with the gaseous nitrogen. That was a little bit of a problem, but it's been resolved.
Yeah, absolutely. We have two supplies that provide gaseous nitrogen to Launchpad 39B, and one of the supply valves that we have, one is our primary, one is a secondary. Our secondary had an issue with the controller. This allows the operator to be able to incrementally adjust how open or closed the valve is. And so once we identified that issue, the team evaluated it and found a good solution to go change out that controller. They've done that work. They have retested that valve and controller working together. And what that was really important for us is that we need to have redundancy, have a primary and a backup, because once we start loading cryogenics, we need to have the gaseous nitrogen to provide an inert system, and it protects us across many different aspects of the core stage and the interim cryo propulsion stage. So really important capability, and the team did a great job identifying the problem and resolving it. And so we're in really good shape that that problem has been cleared, and we're in a good configuration to pick up with cryo loading.
No longer a constraint, a lot of work that went on there and some quick work as well. I've also been listening to the team working another issue, and that is in regards to the left solid rocket booster. Is that correct?
It is, and one of our tests that we do a resistance test, and basically the value that resistance test should show should be between 24.4 and 37.4, and the value we received was 22.4, so just below our nominal configuration.
And this is on an auxiliary power unit, right?
Correct.
That helps control the steering of the booster?
Correct.
Okay.
And so we've evaluated this, and we've looked back at the past history of this measurement. The value we're seeing now is consistent with what we've been seeing over the last several weeks. So although it is outside of our nominal range, we understand that it's consistently here, so we believe that's a valid number. And we also understand that this is not a constraint for us for wet dress rehearsal. We are going to further evaluate it after wet dress rehearsal to understand that consistency at that current value, but it is not a constraint, and our team is working to process a waiver to that requirement. Everybody's on board with that at this point. We're just working through all of the details, and we'll be doing that in parallel with the loading operations.
Very good. And so when that system is fired up, which is pretty close to T0, which you're cutting off before that on the first run, but going past it on the second run, will that be allowed to be checked out?
Absolutely. With this waiver, that allows us to proceed through our planned terminal count operations, the first run and the second run.
Great news. And we also got a weather brief now that we're slipping a little bit in the T0 for today, now around 4:30 p.m., at least as it stands right now. How's the weather looking?
The weather's looking great. We got a great weather forecast. No issues from lightning or storms. So we're in really good shape as it pertains to weather.
Assistant Launch Director Jeremy Graber, really appreciate you being here and sharing the information with us.
Absolutely.
All right. And so we'll continue to monitor the launch team as they move forward. Again, Launch Director Charlie Blackwell-Thompson giving the go for cryogenic tanking. The count will then pick up, the plan to be picked up at 9:20 a.m. Eastern Time, and we are moving forward with the operation here. That's all from now. This is Artemis Launch Control. This is Artemis Launch Control at 9:20 a.m. Eastern Time with an update on the count for the cryogenic tanking of the Space Launch System this morning, the second day of wet dress rehearsal. We have a new T0 time. We were expected to pick it up at 9:20 a.m. Eastern Time, 13:20 UTC time, but that has been delayed by 8 minutes. So our new pickup time for the clock to resume counting, you see in your upper left-hand portion of your screen at T-minus 6 hours, 40 minutes and holding. We will begin that just 7 minutes from now. Again, the new simulated T0 will be 2038 UTC or 4:38 p.m. Eastern Time. The team is configuring the launch vehicle to get ready for cryogenic tanking. First up would be the liquid oxygen tank, and they have started the transfer line chill down for the core stage. The team working through a couple issues this morning that pushed back the timeline, one of them with a gaseous nitrogen line that runs out to the pad in order to purge cavities around the vehicle of hazardous gases. The backup line, a controller on the backup line went down. It's been replaced, and now the system, both the primary and the backup gaseous nitrogen, are up and running. Again, we are now chilling down the transfer line for the liquid oxygen into the core stage. When they do that, they basically flow a little bit of LOX. It pushes some gas down the line and begins chilling it down so that it is conditioned for the full flow of liquid oxygen into the liquid oxygen tank. And that's the update for now. Please stand by for more. This is Artemis Launch Control. This is Artemis Launch Control, getting ready to resume the countdown. Currently in a hold at 6 hours and 40 minutes. Expecting to start the clock in 3, 2, 1. And so the clock has resumed. As you can see in the upper left-hand portion of your screen, we are currently 6 hours, 39 minutes, and 50 seconds and counting. Cryogenic preparations for cryogenic tanking have begun. This is Artemis Launch Control. is Artemis Launch Control with an update on preparations to cryogenically tank the Space Launch System. We've reached a few milestones. The liquid oxygen transfer line has been chilled down. The upper stage helium bottle pressurization is now at flight level. And we are in the midst of the core stage liquid oxygen main propulsion system chill down. So things are moving forward. Our next step is the slow fill for the core stage with liquid oxygen. And that's a big moment when propellant will actually be flowing into the tank. This is Artemis Launch Control. This is Artemis Launch Control at T-minus 6 hours and 21 minutes and counting. We are in the midst of preparing for the cryogenic loading of super chilled propellants into the liquid oxygen tank on the core stage. That is the stage you see in the center of your screen with the 4 RS-25 engines below. We see 2 of them. You may notice underneath there some gaseous oxygen coming out at the bottom, both on the right side RS-25 and the left for the 2 engines that are facing us. That is because we are in the midst of chilling down the main propulsion system. And with that gaseous oxygen getting into the system, you're seeing it start to stream out of the bottom there. This is all to pre-chill down this hardware in anticipation of flowing super chilled liquid oxygen through those lines. is Artemis Launch Control with an update at 10 a.m. Eastern Time on the cryogenic tanking of the Space Launch System. Good morning, I'm Daryl Dale with NASA Communications. Following along the operations here as the launch team communicates. We are currently in the midst of the chill down of the main propulsion system for the core stage, conditioning it with liquid oxygen gas, where they basically opened up the valve to the liquid oxygen cryosphere, which is nearby the pad, and allow some of that propellant to flow forward, pushing cold oxygen down the pipe into the tank through the propulsion system, and we've seen a little bit of it wisp out from the engines below. We are now pulling that liquid oxygen back as the line has been chilled. And the next step, in just a few minutes, we expect to start pumping liquid oxygen into the core stage. Of course, this is all part of wet dress rehearsal for Artemis 1. It's the final major test of the integrated Space Launch System rocket and Orion spacecraft before Artemis 1 takes a test flight. During the test, the launch teams are rehearsing operations to load propellant into the rocket's tanks, conduct a full launch countdown, demonstrate the ability to recycle the countdown clock, and drain the tanks. This will give them an opportunity to practice all of this, the timelines, the procedures that they will actually use on launch day. Again, we're at T-minus 6 hours, 5 minutes and counting, and in just a few minutes we will begin pumping super chilled liquid oxygen into the oxygen tank for the SLS. This is Artemis Launch Control. This is Artemis Launch Control. We have reached another milestone in the tanking of the Space Launch System rocket that you see on your screen. The core stage liquid oxygen is in slow fill. So a pump from the cryosphere that you see to the far right of your screen, that is the liquid oxygen cryosphere. So super chilled liquid oxygen at a temperature of minus 297 degrees Fahrenheit is flowing from that tank that you see there on the far right into the rocket's liquid oxygen tank that sits about right around where the top of the side solid rocket booster is. That would be the one with the NASA worm on it. Down below, as you can see from this shot of the engines, the gaseous oxygen that is in the tank and in the engine system is now flowing out through vents at the RS-25 engines. There are 4 of those engines. You can see 2 on one side in this shot. But you can see now that the flow of the gaseous oxygen has really picked up as it forms a white cloud underneath the rocket and condenses the water vapor around it, which, by the way, it's quite humid here in Florida. We're around 90% humidity, so expect to see quite the visual when the liquid oxygen hits the humid air. The liquid oxygen tank is quite large, one of the largest in the world. It can handle 196,000 gallons of liquid oxygen. But most of the core stage tank is actually for the liquid hydrogen. It is a massive tank. We'll get into flowing that a little bit later at the completion of liquid oxygen. Of course, the two going together is what gives this rocket its propulsion. At its most fundamental level, you can look at these Space Launch System engines. They're called RS-25s, and these particular ones come from the Space Shuttle program. They can be thought of as extremely large water nozzles. You have a single chemical reaction. On one side, liquid hydrogen. On the other, liquid oxygen. Together, they have a chemical reaction that produces an incredible amount of energy. But the byproduct is water vapor. And so the engine produces its thrust by converting that chemical energy to kinetic energy in the form of high velocity water vapor. The core stage liquid oxygen slow fill is the longest of the operations for tanking today. It's more than 2 hours long, roughly 2 hours and 40 minutes to fill that liquid oxygen. Liquid oxygen is extremely dense. Next up, as I mentioned, we're going to begin chilling down the transfer lines for the liquid hydrogen side of the rocket. That'll be coming up in just about a little less than 10 minutes. For now, this is Artemis Launch Control.
And if you're just joining us, welcome here to the launch pad. You're looking at a live view of Launch Complex 39B at NASA Kennedy Space Center, where NASA has officially begun fueling operations of the Space Launch System, or SLS, that will soon launch from the Artemis 1 mission later this year. The core stage liquid oxygen fueling slow fill has gone underway, and we'll see fast fill begin here shortly. Coming up next, we're expecting to see that liquid hydrogen chill down begin, expecting at L-6 hours and 5 minutes, so just under 20 minutes from now. If it's your first time here, though, welcome. My name's Zach. I'm founder and host here at the Launchpad, here at TLP. It's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. And we have our team here, and we're answering your guys' questions live in the chat as we count down through today's wet dress rehearsal program. You can send those questions in the chat by tagging us at the Launchpad, or tweet us at TLPN_official. We're also live tweeting updates throughout today. We're also hanging out over in the TLP Discord with our community. You can feel free to join us over in live comms. Both of those are free for you to join, but you can see there a live view from the engineering cam of that fueling of the liquid oxygen underway. Lots of venting from under those RS-25 engines, really starting to show this SLS rocket coming to life. First time we've ever had these live views shared out publicly from NASA. They, of course, had these views during the first 3 wet dress rehearsal attempts, but because of that, they were able to review their programming and decide what they wanted to show during this time. So we have the wide shot, and then we have this close-up of those RS-25s, and you can see those starting to form that white ring because they're cooled down and getting all filled up in that lower part of it being fueled. We do expect to see some other animations from NASA time to time showing the status of the fueling, so we'll cut those in when we can. Keeping an eye on weather, everything is looking good. Still, the only condition we're really watching is that condition of lightning, but it's at 10% or less, which is exactly what we need for a forecast to be able to continue with fueling operations, so they have continued on. Now, this fueling will take a couple of hours before it fully fills those tanks, and then they will be remaining to top them off as they approach that countdown. Now, one of the biggest questions we always get off the bat is, why are there 2 countdowns? There's an L- and a T-. Easiest way to think about this is L- is your real world time. In 6 hours, 21 minutes, and 20 seconds, that is when we expect T0 to occur on the first of the 2 wet dress rehearsal runs we're expecting today. T- is the operational clock, so there is a 30-minute built-in hold remaining in today's countdown that will occur later on in the count, and that T- clock will then change to an H- and sit there for 30 minutes at a specific time before it resumes. Once it resumes, that's when we'll see the L- and the T- clock be matched up. So T- is operational, L- is your real world time as we go through fueling. Very similar to what we saw with the space shuttle program. It's been a while since we've seen that, other than with the occasional ULA launch, so something we'll be getting used to, and we will have a video breaking that all down here on the launch pad in the next week or 2 that breaks down all the different countdowns you guys can see coming up over the next couple of years as we enter really this very busy era of space exploration, of heading back to the moon. As always, if you guys have questions, send those in the chat. Tag us at the Launchpad. We'll be answering those. I see we got one from Train Kid. Are they going to fuel up the ICPS also, or just the core stage? We are going for a full wet dress rehearsal today, so they are going to be fueling all the tanks of the SLS rocket and preparing them basically as if they were going to go for launch. The SRBs, of course, are already ready. They're solid rocket fuel. But the core stage will be filled, the ICPS will be filled. Basically, if they hit a couple more buttons, they could launch the thing, but we're not ready for launch. There's still more stuff that needs to be loaded on the rocket. The flight termination system has to be activated. Today is kind of like a static fire, but we're not firing the engines. We're getting all the way down to T-minus 30 seconds. We're going to enter a hold. They're going to recycle the clocks back to T-minus 10 minutes. Hold there. Takes about an hour for that recycle, and then they're going to resume the count all the way down to T-minus 9.34 seconds. Then they're going to hold, scrub, and then go through fuel draining operations of the SLS rocket as they continue through today's operations. So that's what we're expecting, 2 wet dress rehearsal run-throughs over the next couple of hours. Obviously, we still got a little bit of time for that first run-through. T0, if we were running all the way, T0 expected 6 hours, 19 minutes from now, as long as we don't have any more delays in the countdown. Because we can see that venting nice and clearly here, and we are getting updates every 30 minutes from NASA via commentary, as well as breaking in updates as things have progressed in the timeline that are against the timeline. So some great communication from NASA this time, keeping us in the loop about what is actually happening. As we get started, though, let us know in the chat where you're watching from. We got people all over the world tuning in, as well as share out the broadcast, and we encourage you to do so. Invite people in. This rocket is what's going to kick us off going back to the moon, and the next time we see this rocket out at the pad, it will be launching back to the moon, and then in a couple years, we are going to see people board that rocket and go back into lunar orbit for the first time in over 50 years, which is absolutely exciting. Mark, that's awesome. We'd love to connect with Les if possible. We always want to share some real stories with people, so feel free to pass our info along. We're working on an interview series, and this is out to all of you. We're working on an interview series that will be launching here soon called Behind the Console, where we sit down with the real people of NASA and the space industry that are behind the console, that don't get kind of, the fame of the press conferences all the time, who are doing the real hard work of making these rockets possible and are working on some of this science. So stay tuned for that. We got a bunch of ones coming up over the summer, so stay tuned for that. Thanks so much, Mark. Appreciate it. Hello from northeast India. We got Spain, India, Georgia, USA. Stratoblasters on the couch. That's the best place to be watching. But it's great to have all of you here. We're going to take another quick commentary break, turn up the space ambient tunes, and watch as we watch Launch Complex 39B come to life with the Space Launch System as we count down towards the wet dress rehearsal of Artemis 1. Stay with us.
Artemis Launch Control, we are now in core stage fast fill for liquid oxygen. You can see the activity has really picked up underneath the core stage, and it's 4 RS-25 engines. That's gaseous oxygen, or what they call GOX, flowing out of the vents underneath the engines. So the fill rate has picked up substantially into the tank. They speed up the pumps to increase the amount of flow that goes into the core stage liquid oxygen tank, which can hold 196,000 gallons of liquid oxygen. The launch team is preparing now for liquid hydrogen to fill. I'm listening right now to the launch team, so I may pause in commentary to catch any important updates as they arrive. It's important for the launch team to load these propellants in the proper series and at the proper levels. You can see in this shot right here what is called an aft strut. It's about 2/3 your way up your screen, and attached on either side of each booster is an aft strut. It's the horizontal metal piece attaching it to the center core stage. Now this not only provides structural connection from the core stage to the rocket boosters, but also there's data going through there. And so as it relates to the flow of propellants, super chilled liquid oxygen, which comes in at a minus 297 degrees Fahrenheit, can shrink the core stage a little bit. It's also extremely dense, so it's quite heavy. That weighs down the core stage. And so there is a engineering constraint to that particular strut there that requires them to fill the liquid oxygen tank to no more than 50% before they get started with the liquid hydrogen. Again, core stage is in fast fill. A major milestone reached in today's tanking of the Space Launch System with Orion spacecraft at the top. This is Kennedy Launch Control. This is Artemis Launch Control with an update on the cryogenic tanking of the Space Launch System, NASA's Mega Moon Rocket, as it's called around here. You're looking at a shot of the core stage, which is currently in fast fill for liquid oxygen. The level is less than 15%. At the same time, we've just gotten the go from the NASA test director to proceed with filling the liquid hydrogen tank, which is the largest tank on this rocket. The tank holds 537,000 gallons of liquid hydrogen, and it's super chilled down to a minus 423 degrees Fahrenheit. Stand by. And so with the go to proceed for liquid hydrogen fill, the team will now pre-chill the transfer lines. And from there, they'll go right into liquid hydrogen slow fill. This is a major milestone. As you may recall from previous wet dress rehearsals, there was a leak in the tail service mast and the umbilical. That leak was fixed, so this is a big moment for the team as you continue to see the liquid oxygen vent through the engines there, the RS-25 engines, former space shuttle engines that are now being used, been refurbished, and put on the moon rocket. We'll let you know an update when the liquid hydrogen begins to flow. For now, this is Artemis Launch Control. At T-minus 5 hours, 26 minutes and counting, this is Artemis Launch Control here at the Kennedy Space Center in Florida with an update. The launch team just gave the go to begin liquid hydrogen slow fill. We are currently filling the liquid oxygen tank, and on your screen, that is why you're seeing the clouds coming from the underside of the core stage. Those are vents, and as the core stage fills with liquid oxygen, it vents out gaseous oxygen below. Now the liquid hydrogen will begin with slow fill, and you may have heard me mention that when describing the liquid oxygen stage. They filled at slow fill and then moved to a fast fill. Currently, liquid oxygen is in fast fill. Liquid hydrogen will begin slow. The reason for that is to properly condition the vehicle. The engineers are trying to prevent thermal shock to the system by flowing too much cold, super chilled propellant too fast. Inside the tanks, the propellant tanks of this rocket, is an anti-vortex device, anti-swirling. And so when the propellant level goes above that device in the tank, that is the cue to end slow fill and begin the fast fill. And it will fast fill all the way until 98% filled. And at that point, it will slow back down again and top off the rest of the way to 100% at a slow rate. So shortly we will have both propellants flowing into the core stage of the Space Launch System. A big milestone here for the launch team as they move to completely tank this rocket and perform a terminal countdown. That expected at 4:28 p.m. Eastern Time. This is Artemis Launch Control. T-minus 5 hours, 6 minutes, and counting in wet dress rehearsal for Artemis 1. I'm Daryl Nail with NASA Communications. If you're following along, we are performing cryogenic tanking of the Space Launch System rocket with the Orion spacecraft at the top. NASA's lunar exploration program is called Artemis. Artemis missions will turn science fiction into science fact as we make new discoveries, advanced technologies, and learn to live and work on another world. And this rocket is the first step to getting there. Wet dress rehearsal is the final major test of the integrated Space Launch System rocket and Orion spacecraft before we conduct the Artemis 1 flight test launch. Teams have been rehearsing their operations, been loading propellant into the rocket's tank. We're over 15% now for liquid oxygen. And the liquid hydrogen team is currently chilling down the propulsion lines to prepare to flow propellant. They've been given the go to flow liquid hydrogen, but they have not flowed it yet. They have asked the launch director, and she agreed to allow them to increase the flow rate a little faster than they normally would to increase getting back into time with liquid oxygen. These propellants are flowed in series. First, we had liquid oxygen a little more than an hour ago. It's currently in fast fill. It can flow up to a certain point, 49% filled, before we have to start flowing some liquid hydrogen. The liquid hydrogen team is now chilling down the upper stage, the line to the upper stage vent valve. If you were following previous wet dress rehearsals, there was an issue with some pressure spikes in the liquid hydrogen line. And so they're working through a procedure that allows them to chill down that line in time. Stand by. The liquid hydrogen team, again, is going to step up the chilling of the system ahead of flowing that propellant. The liquid oxygen team, meanwhile, will slow down their pump so that they don't run into what's called an aft strut constraint. And if we can take a look at the close-up shot of the engines, I'll explain that. As the liquid hydrogen tank starts to fill, they must do that at a rate that's connected to the liquid oxygen side. Liquid oxygen cannot go beyond 49% before liquid hydrogen reaches 5%. That's called the aft strut constraint. So again, liquid hydrogen team has been given the go to flow propellant into the tank. There's no propellant actually in the liquid hydrogen tank at the moment, but they are chilling down the propulsion system, and they are chilling down the system in preparation of flowing that super chilled liquid hydrogen at minus 423 degrees Fahrenheit. The liquid hydrogen tank is the largest tank in this rocket at 537,000 gallons. Together, liquid hydrogen and liquid oxygen come together in the engines of the Space Launch System to produce water vapor at a very rapid rate, and that provides the propulsion for the core stage, along with the 2 solid rocket boosters that you see on the side of the rocket there. So again, we're awaiting the first amount of propellant, liquid hydrogen, to go into the tank. It is flowing through the lines now up to the upper stage skid to pre-chill that. We'll let you know when we've got liquid hydrogen flowing. This is Artemis Launch Control. This is Artemis Launch Control with a quick update at T-minus 4 hours, 58 minutes and counting. The liquid hydrogen is now flowing into the liquid hydrogen tank in the core stage. We were in a state known as slow fill, but previous wet dress rehearsals added a procedure in which the liquid hydrogen team pre-chills the upper stage propellant line and the skid where it goes into the ICPS, the upper stage. And so that has been properly conditioned now for liquid hydrogen. And so liquid hydrogen is now flowing into the liquid hydrogen tank. And so we have propellants going into the rocket, both liquid hydrogen and oxygen at the same time. A good milestone here for the Artemis launch team. This is Artemis Launch Control. This is Artemis Launch Control at T-minus 4 hours, 37 minutes and counting into wet dress rehearsal for Artemis 1. Space Launch System rocket is on the pad at Launch Complex 39B here at the Kennedy Space Center in Florida. I'm Daryl Nail with NASA Communications. We've got an update for you. The liquid hydrogen is now in fast fill. Again, liquid hydrogen is now in fast fill. We have both now, liquid hydrogen and liquid oxygen, in fast fill going into the tanks of the Space Launch System. These are massive tanks, and propellant is moving quickly. We've also satisfied the aft strut constraint, which if we take the engine shot, we can talk about that just a little bit. The aft struts are the horizontal attachment points from the solid rocket boosters on either side of the core stage. The vehicle moves during fueling. It's very much alive as these super chilled propellants go into that tank. It becomes heavier. Some of the metal shrinks. And so for that reason, the propellants are put in proportion to each other. And I was just updated by the launch team that during wet dress rehearsal number 2, they changed that aft strut constraint so that as long as the depletion sensors in the bottom of the liquid hydrogen tank are covered, then the aft strut constraint is met. And so that allowed the liquid hydrogen to go into fast fill. And again, liquid oxygen already in fast fill. The propellants can be tanked at the same time. In the core stage, once one is complete, the next one will start. And we do expect, even though the liquid hydrogen is the larger tank at 537,000 gallons, it will finish ahead of time before the smaller liquid oxygen tank. Liquid hydrogen is extremely light. Liquid oxygen, extremely dense. And so the 196,000 gallon liquid oxygen tank and the filling of that propellant tank is the long pole in this operation today. So we are getting good propellant fill at the moment. We've got good weather in the area. Everything proceeding nominally. And the current levels on the tank, just to give you an update on that, the liquid oxygen tank is at roughly 38% filled. Again, the LOX tank, 38% filled. Hydrogen, less than 5%. And we're turning forward. T-minus 4 hours, 34 minutes and counting. This is Artemis Launch Control. At T-minus 4 hours and 21 minutes and counting, this is Artemis Launch Control with an update of the tanking operation. Currently, we are in stable fast fill with liquid hydrogen and have already reached the 20% fill mark for liquid hydrogen. On the liquid oxygen side, we are at 46%. Again, liquid hydrogen at 20%, liquid oxygen at 46%, both propellants flowing in stable fast fill. We are getting ready to reach the completion of another milestone. The team has given the go for the upper stage liquid hydrogen RL-10 engine system purge. This is essentially where they'll flow helium through the system to condition it, get it ready for filling liquid hydrogen into the upper stage. Listening to the launch team right now. Operations continuing nominally, and that's a good sign there. Propellant flow continues. Again, the go has been given for the team to do the helium purge to prepare the upper stage for liquid hydrogen tanking. This is Artemis Launch Control. This is Artemis launch control at T-minus 4 hours and 6 minutes in wet dress rehearsal for Artemis 1. We are currently in the midst of cryogenically tanking both liquid oxygen and liquid hydrogen into the Space Launch System core stage. It is at the center of your screen there. The Space Launch System rocket with 2 solid rocket boosters on either side. This is what's going to take us back to the moon with a test flight in Artemis 1. And the idea for NASA is to explore not only the moon but also Mars. Test technologies by going back to the moon, prove them out, and then ultimately use them to go on to Mars and explore our universe and beyond. So I want to give you an update on the tanking operation. Currently, for liquid hydrogen, we are at 52% filled. That is the largest tank in the tanks, over 500,000 gallons. And then on the liquid oxygen side, we are currently at 58% filled. Things are looking good so far. Stable fill rate. The team continues to work, preparing the upper stage now for its 2 tanks to be filled. They'll go much faster, much smaller tanks. I want to talk about the engines that you see there in this shot. Some nice history to tell you about. So at the bottom of the screen you see the engine nozzles, and those are RS-25s made by Aerojet Rocketdyne, and they are former space shuttle engines. And in fact, they have flown on previous flights, I should say. The one on the left, that's given the identifier of 2058, and it has flown a total of 6 space shuttle flights, including the first flight of that RS-25 engine. Notched a total of 4 flights, including STS-114, which was NASA's return to flight after the Columbia tragedy. You don't see the other 2 from this particular view, but they have a lot of history as well. The back left engine is 2060. It has a total of 3 flights, including STS-135, the last space shuttle mission. And the last and 4th engine, but certainly not the least, is 2045. I'm sorry, I meant, if I didn't say 2060 for the 3 flights of STS-135, that's what I meant, 2060 for STS-135. And then the last one, 2045. This is the most veteran engine. It has 12 flights. First with STS-89 in January of 1998. And the last was STS-135 in July of 2011. And also, it flew astronaut John Glenn on his last flight. That was STS-95. The RS-25 engines create 2 million pounds of thrust to help power the Space Launch System. These engines are so powerful that if it were generating electricity instead of propelling rockets into space, it could power 846,591 miles of residential streetlights. That's a street long enough, not coincidentally, to go to the moon and back and circle the Earth 15 times. A lot of history there with the RS-25s. Again, we're proceeding forward with the tanking of the Space Launch System here at the Kennedy Space Center. We're in good shape so far, and we'll keep you updated as we go along. For now, this is Artemis Launch Control. Artemis launch control at T-minus 3 hours, 54 minutes and counting. Quick update on the fill percentage for the liquid hydrogen tank and the liquid oxygen tank. We are at 67% filled for liquid hydrogen. It has passed the fill rate for the liquid oxygen, which is currently sitting at 63%. Again, 67% filled for liquid hydrogen, 63% filled for liquid oxygen. We continue to successfully fill the Space Launch System core stage with cryogenic propellants. These are super chilled, extremely cold. And as you can see at the bottom of your screen, that's liquid oxygen venting out from the bottom, creating the cloud of condensed air. This is Artemis Launch Control. At T-minus 3 hours, 34 minutes and counting. This is Artemis Launch Control with an update for the 12:30 hour, 12:30 p.m. Eastern Time. We continue to load cryogenic propellants into the core stage. That picture there showing you the venting off of the liquid oxygen at the bottom, condensing the air and creating those clouds. The liquid oxygen tank currently at 76% full, and we just passed a milestone for the liquid hydrogen. We are currently at 98% full, so we have stopped fast fill and have begun a stage known as liquid hydrogen topping. So there are sensors inside the tank that once it reaches that level, it then slowly begins to add propellant as it approaches the 100% mark. That prevents propellant from burping out of the system, so to speak. So good news there. The team working their procedures and moving along. We'll have an interview with the technical assistant to the launch director here in just a few minutes. Get caught up on what they've been working on to this point so far. This is Artemis Launch Control. This is Artemis launch control at T-minus 3 hours, 26 minutes and counting. We have an update on the propellant fill for the core stage. The super chilled liquid oxygen is now at 80% full in the core stage tank, and you can see the venting there coming out of the bottom where the RS-25 engines, the old space shuttle engines there that have been refurbished for the SLS program. They're venting. Things are looking good there. With respects to the liquid hydrogen tank, that is currently 100% full. And so now we have moved to a replenish mode where the super chilled liquid hydrogen, which is at minus 423 degrees Fahrenheit, it will boil out there in the hot Florida sun inside of the tank. And so that basically reduces the amount of propellant that's in there. And so the team just goes to a replenish mode where they are essentially keeping enough in there to keep it right at 100%. I've got the technical assistant to the launch director joining me, Wes Mosdale, coming on, and appreciate you coming on over and taking a break from the launch team.
Hey, good afternoon, Daryl. It's great to be here. It's a great start to our wet dress rehearsal so far. As you mentioned, we're just got into replenish on hydrogen, so that tank is full, and we're getting very close on LOX as well, and we'll be getting into topping and replenish there shortly as well. So that both the core stage liquid oxygen, liquid hydrogen systems are performing great today, and it's great progress so far.
Been a lot of work to get to this point, surely there's a lot more work to do, but you got to be feeling good at this point.
We're feeling really good. So now that we're in replenish on core stage liquid hydrogen, our teams are getting ready to start the chill down of the upper stage liquid hydrogen system as well, and that'll be the next step in our operation today. Will be to start loading that liquid hydrogen into the upper stage.
Tanks are much smaller, so that fill will go much quicker.
It will be significantly quicker. Yes, sir.
All right, let's talk a little bit about one of the issues at the beginning of today's operation. There was a constraint to what would be launch, but also wet dress.
That's correct. Yeah, we had an issue with it's actually a valve that operates when we start up the booster thrust vector control hydraulic power unit there. It depressurizes the hydraulic system and allows the turbine to spin up as we start that system up. Our teams went off and looked at the data from the past few times we've operated that valve and verified that it is indeed operating normally. We'll start that system as we get into terminal count later on today, and assuming that starts normally, that will allow us to continue through wet dress. So the teams did take that data up to the mission management team, since we were just slightly outside of our requirement there, reviewed the data with the mission management team, and the mission management team approved us to continue today. So that constraint has been cleared, and we will go to press forward with WDR. Very
good. And that's the booster on the right if you're looking at our screen there. And this unit, as you mentioned, this is an auxiliary power unit.
That's correct. It essentially provides hydraulic pressure to power the thrust vector control system, the steering for the booster nozzle during ascent.
And those outside boosters, they really control the flight in the early going of this, when it is launching, right? Because even though, as I understand it, those nozzles move, maybe articulate 1 degree or so, they can have great influence on the steering of the rocket.
That's correct. Obviously, the booster is providing the bulk of the thrust for that first 2 minutes or so of flight. So those nozzles, as you said, are providing a bulk of the steering and don't have to move to move very far. Yes.
And it gives it great steering as well. All right, Wes Mosdale, technical assistant to the launch director. Hey, appreciate you stopping by.
Thanks for having me. It's great to be here today.
All right, let's continue with our good luck and good fortune going forward today. For now, this is Artemis Launch Control. T-minus 3 hours and 7 minutes here at the Kennedy Space Center, where the Space Launch System and Orion spacecraft is on pad 39B. Cryogenic propellants going into the tank. We have filled the liquid hydrogen tank. It is at 100% and currently being topped. And if you look at towards the top of the kind of orange colored center stage called the core stage made by Boeing, you can see the venting of the liquid oxygen, and that's because we're nearly at the top. We are 90% full for liquid oxygen, nearly completing propellant fill on both massive tanks inside that core stage. We're running a little behind on the tanking for the upper stage. Probably about a half hour or so. The tweaking of that upper stage skid took a little longer than expected, and so we're awaiting the chill down for the upper stage to begin flowing propellant to that part as well. The upper stage, called the interim cryogenic propulsion stage, or ICPS. This is the stage that will give us the big boost to the moon. I was just listening to the launch team give us an update, and the upper stage is now in chill down. They've given the go, and so that's good news. That's for the liquid hydrogen side. So with the liquid hydrogen side complete for the core stage, we can now begin working on that upper stage portion of the rocket. Wet dress rehearsal is the final major test of the integrated Space Launch System rocket and Orion spacecraft before the Artemis 1 flight test launch. The team has been working since early this morning. Teams taking shift. They officially began the 2-day operation starting Saturday night at 5 p.m., preparing the pad, configuring the vehicle, powering up systems. And then today, the big day, the tanking of the rocket, as if it were launch day. That got started with a pre-brief meeting at 6 a.m. Eastern Time. There was a delay to tanking of several hours, but then we got started with that and have had success in getting the liquid oxygen and liquid hydrogen into the core stage ever since. The team says they're feeling good at this moment, and we continue to monitor their progress. Again, we're looking now to the next step, which is the filling the propellants in the upper stage of the rocket. Stand by for more updates. This is Artemis Launch Control. Artemis launch control at T-minus 2 hours and 55 minutes. On your screen there is a graphic that shows the progress so far. And you can see that we have the liquid hydrogen tank completely full. All 538,000 gallons of super chilled liquid hydrogen. And then on the left you can see the progress for liquid oxygen. We are 98% full. The tank there, you see the numbers rising as it reaches its capacity of 196,000 gallons. That temperature is a super chilled minus 294 degrees on the LOX side. On the liquid hydrogen side, it's minus 460. Our thanks to the team, the Orion Communications team at Johnson Space Center, for putting this together for us. We had some technical issues early on, but we've got those straightened out. Graphic looks good. We will not have a graphic for the upper stage, however, but I'll report that out as we go along the way. Meanwhile, we're closing in on replenish for the liquid oxygen side, and that's a big milestone there, with the core stage nearly fully tanked. Chill down of the upper stage has begun, and we should get some propellant flow shortly. Hasn't begun yet, but we're expecting that soon. And of course, I'll keep you updated. This is Artemis Launch Control.
And if you're just joining us, good morning, good afternoon, depending where you're joining us from, or maybe good evening. You're looking at a live view of the bottom part of the Space Launch System at NASA Kennedy Space Center out at Launch Complex 39B, where NASA continues to go through today's Artemis 1 wet dress rehearsal. On your screen now is a live look at some telemetry they are providing of the core stage liquid oxygen and liquid hydrogen propellant loading. You can see there the liquid hydrogen is fully fueled, 538,263 gallons at full capacity, and there the core stage is currently just under 2,000 gallons short of its capacity as well, at 99% full. You can see there the live temperatures as well. The core stage liquid oxygen being held at negative 294 degrees, with the liquid hydrogen at negative 460 degrees, both in Fahrenheit there. As we continue the countdown through T-minus 2 hours, 49 minutes, 5 seconds, and counting. The L- clock, that's your real world time clock. So we are currently 3 hours, 18 minutes, 55 seconds and counting away from the T0 of the first of 2 wet dress rehearsal runs we are expecting today. Today, in this first run, they're going to run the clock all the way down to L- and T-minus 30 seconds. They're going to enter a hold. They're going to recycle back the clock to T-minus 10 minutes. That takes about an hour to do, and then they're going to resume the countdown and take that countdown clock all the way to T-minus 9.34 seconds. They will order a hold and then a scrub. They will safe the vehicle and then work on propellant offloading of the vehicle. So a busy day still ahead of us. We've still got, even on top of the time on your screen now, that 3 hours, 18 minutes, we have at least another hour and a half on top of that to conduct the second wet dress rehearsal run, should things proceed well today. But as always, here at the Launchpad, we're here to answer your guys' questions live, so you can send those in the chat by taking us at the Launchpad in the chat, and we'll be answering those for you. If it's your first time here, though, welcome. My name's Zach. I'm the founder and host here at TLP. Here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together, and it's great to have you here joining us for this really exciting day to see the wet dress rehearsal finally become complete. Hopefully things have been proceeding well. We had one issue early this morning with one of the valves, but so far everything else has been proceeding nominally through the countdown. Some things taking a little longer to chill and cool down, but that's why they build in time in these countdowns for things like that to happen. If it's your first time here, though, let us know in the chat where you're watching from and it's your first time. Make sure you follow us over on our Discord. We're live tweeting updates about today's wet dress rehearsal, but also about other activities that have happened. We've had an update that the International Space Station was expected to conduct a test with the Cygnus engine to test it being able to reboost the International Space Station for the future, to not have to rely only on the Russian crafts to do so. That test started, but it had a shutdown. It did not conduct a full test, and it was aborted and now is under review. So we're tweeting about that, as well as making sure we stay on top of all other space news updates. If you want to join an awesome Discord, awesome space community, you can join us over on our Discord. Totally free to join, and you can jump in there. We're hanging out in live comms, watching today's wet dress rehearsal and just talking how it's going, about everything in space. And take a moment and consider checking out our shop at the launchpad.store. We just dropped a bunch of brand new stuff and launched our brand new store, and you can get your SLS schematic tees, detailed and more simplified, available there. Shipping worldwide is available, and yes, we do take Dogecoin. But you're looking at a live view of Launch Complex 39B at those RS-25 engines with that little bit of a liquid oxygen kind of cloud coming off of them as NASA continues to approach that filled point, and we should be here 100 gallons away. We'll wait for the graphic to update. It says 100%, but we should be at the point where we are at 100%, the core stage, for the first time ever of a fully stacked core stage at a launch complex, fully fueled. Looks like their graphic reset there a little bit, but the core stage is fully fueled, and we are waiting for the ICPS fueling to begin here shortly. Again, keep sending in your questions by tagging us at the Launchpad, and we'll be answering those live. Things are proceeding nominally towards the first of the 2 wet dress rehearsal T0s that we are expecting here today. So stay with us right here on the Launchpad.
T-minus 2 hours and 38 minutes and counting as we look at the core stage and the 2 solid rocket boosters at the bottom of the Space Launch System. We have an update for you on the cryogenic tanking. We are now in replenish for both the liquid oxygen and the liquid hydrogen. You see the liquid oxygen venting down there through the engine nozzles, those RS-25 refurbished space shuttle engines. And we're also venting out of the top of the rocket for the liquid oxygen as we slowly replenish the amount that is lost due to boil off. At minus 297 degrees Fahrenheit and a hot Florida day, that combination means that we'll be boiling propellant inside that tank, and you can see the venting happening at the top of the core stage as that comes off. I want to make a correction on a graphic that we put up. The temperature of the liquid hydrogen was reported to be minus 460 degrees Fahrenheit. That was inaccurate. It is actually minus 423 degrees Fahrenheit. We are also in replenish for liquid hydrogen and have been so for some time now, and that has allowed the team to start working on the upper stage. They pre-chilled the system for the upper stage of the rocket, the interim cryogenic propulsion stage, and we are now fast filling the liquid hydrogen tank on the upper stage. It's good news as the liquid hydrogen team continues to work that. This is wet dress rehearsal for Artemis 1, the mission that will return us to the moon and beyond. The rocket that you see there is capable of sending the Orion spacecraft beyond the moon and then back on a test flight that will be scheduled once a successful wet dress rehearsal has been completed. And so far, we're looking good at this point. It's a warm Florida day today. As you can see from this shot, the sun is shining bright. We got a good weather forecast to begin our tanking today. And we continue to tank with the upper stage. Stay tuned for more updates. This is Artemis Launch Control. T-minus 2 hours and 21 minutes. Just heard from the launch team, the liquid oxygen team, that the core stage liquid oxygen tank is in stable replenish. That's good news. Liquid oxygen tank towards the top of the core stage. For the upper stage, we are currently in fast fill for liquid hydrogen. We have not begun the liquid oxygen side of the upper stage, which you see there on your screen. The upper stage is the interim cryogenic propulsion stage. This is the stage that's going to power the Orion spacecraft to the moon. It sits halfway in the orange portion of the vehicle and halfway in the white towards the top of the rocket. It puts out about 24,750 pounds of thrust in space and can accelerate to more than 24,500 miles per hour in order to escape Earth orbit. It's built by United Launch Alliance in Decatur, Alabama. The engine is an RL-10 with a nozzle that extends out once it gets to space, kind of telescoping out. So again, we're running a little bit behind on the liquid oxygen for the upper stage. We'll continue to monitor that. Replenish on the liquid oxygen side for the core stage, and it is in stable configuration as of 1:45 p.m. Eastern Time. This is Kennedy Launch Control. 5 minutes past 2 p.m. Eastern Time. This is Kennedy, the Kennedy Space Center with you. T-minus 2 hours and 2 minutes and counting. We've been given the go to chill down the upper stage for liquid oxygen loading. But the team right now is also working an issue with the liquid hydrogen. They are getting some data that says there's a leak, a liquid hydrogen leak in the quick disconnect that takes the bleed for the engines. Team is currently evaluating that situation. Of course, any leak of liquid hydrogen is something to be concerned about for the launch team, as it is a hazardous gas. And they want to understand this situation fully before they take any action. So stand by and we'll have more information as it's available. This is Artemis Launch Control. This is Kennedy Launch Control. Got a few things going on to update you about at the moment. Our liquid oxygen for the upper stage is now in stop flow. There was a pressure limit that was exceeded on the upper stage skid. The team is working to understand that more fully. If we go out to the wide shot, we actually won't see it. There's another issue with the liquid hydrogen. Apparently, it's possible some liquid hydrogen that goes out to a flare stack where the team bleeds off the liquid hydrogen and then it burns. It is burned with a propane flame. There's a small grass fire out there that's burning. Could have had some, the team suspects that some burning liquid hydrogen may have burped out of that flare stack and set the grass on fire, but Currently, they're looking at that. They've got their cameras trained on it and are monitoring that situation. Again, it's just in an area not far from the launch pad at the liquid hydrogen flare stack. Again, an area that is intended to burn excess liquid hydrogen that is bled off of the rocket. And then we're continuing to work the situation with a detection of a leak on the quick disconnect for the core stage. Stand by. It's the core stage quick disconnect for the liquid hydrogen. They've detected a leak and are trying to understand that. So the team working some issues right now. Of course, we'll let you know how these situations impact launch. We're tracking them closely. For now, this is Artemis Launch Control.
And if you're just joining us, welcome here to the launch pad. You're looking at a live view of Launch Complex 39B at NASA Kennedy.
Grass fire. This is Artemis Launch Control. I was just informed by the launch team that there may have been something that was burning inside the flare stack. It's not liquid hydrogen that came out and set the fire. More likely something that was already inside that may have settled inside the pipe when it came out. The liquid hydrogen is burned at the flare stack with a propane flame. This is liquid hydrogen that is coming out of the rocket that is bleeding as it's flowing through the rocket, coming out of the engine. There's a connection there out to a flare stack halfway between the propellant tanks and the rocket. And something came out of that flare stack that caught the grass on fire. The team is watching it, monitoring it, doesn't expect it to be an issue at this time. It's a small plume of smoke coming out of the grass. This is Artemis Launch Control.
And if you're just joining us, welcome here to the launch pad. Again, you're looking at a live view of Launch Complex 39B at NASA Kennedy Space Center, where teams continue working through today's Artemis 1 SLS wet dress rehearsal. We've just been informed of two issues that are occurring out on that launch site that aren't really visible to us on the cameras. The first is that the core stage quick disconnect is remaining still having a leak. This is actually what we saw happen during the third attempt back in April, and it sounds like we're having the same issue again. Something that they can only detect once they're at full pressure, and this is something that they did not detect when they tried to pressurize it in the VAB. So it'll be very interesting to hear a review once they complete this test or how far they're able to go. The other issue it sounds like they are working on now is with the ICPS, the interim propulsion stage. That's the top part of the rocket between about half of the orange cone and then halfway into the white part under Orion. It sounds like they were having a pressure issue that when they were trying to load the liquid oxygen or hydrogen for that stage, that it was not at a pressure that was within their parameters, and then they have had a slowdown, if not a stop, of that loading at this time. The core stage still remains safe at this point, fully fueled, and is in replenishment mode, so the systems are just topping that booster off as it burns off the excess LH2 and liquid oxygen in that stage, and we're still waiting for completion of fuel loading in the ICPS. But this is something that we did not want to see. We wanted to see a perfect run through today, even with that with the delay this morning with that valve. That was something on ground support. It wasn't a rocket thing. Now we're seeing things that are very critical to operations, that are part of the mobile launcher, that we need to see run correctly. There's a live view looking at the engineering cam at those 4 RS-25 engines and the 2 SRBs on the one on each side there. You can still see that venting coming off from them. That we're going to see that for hours to come, even if they were to scrub at this point. We're not saying they're going to do that at this time, but they are proceeding to do a review of that pressure and of the quick disconnect leak. These are two things we did not want to be hearing. Right now, we are T-minus 1 hour, 50 minutes and counting. We are expecting a built-in 30-minute to hold to begin at T-minus 10 minutes. And that is where they will hold for 30 minutes. They can hold longer if they need to, and we'll see if they get that far down into the count. It all depends on how fueling of that ICPS stage goes. Critical stage on that's what actually gets us in our translunar ejection to orbit to the moon. So we need to see that. Dan commenting in the chat, wasn't a hydrogen leak at the quick disconnect one of the things they pulled it back to the VAB for? You are 100% right, Dan. That was something that they did have to do and was one of the reasons. The main reason they pulled it back to the VAB was because Air Liquide, the supplier of their gaseous nitrogen and ground system stuff, said they wanted to do upgrades to this pad. They've wanted to do it for a while. They kept getting put off by both NASA and Air Liquide, and it wasn't required for SLS for these first missions. For Block 2 it would be, but for Block 1B it wasn't. They did the first wet dress rehearsals and realized, no, we actually do need this upgrade. Air Liquide said, we'll come in and do it, but we need the pad. So NASA said, fine. They needed 2 weeks, so we'll roll the VAB back, work on the valve issue that they had on the rocket, and look at the quick disconnect. Through the reviews, they were not able to get the quick disconnect issue to occur again within the vehicle assembly building, from the reports that we have heard in the press briefings. But they did some changes and fixing there, and thought that they had fixed it, but clearly at this point they were not successful in being able to do that, as they're still having some sort of issue. Keep in mind, this is why we test. We do wet dress rehearsals to make sure that we know everything works. This is why we do not put people on the first rocket. But keep in mind, Artemis 1 will not have a crew. Artemis 2 will. The next SLS we build, we are putting people on. So this test needs to go well. This launch needs to go well, and they are going to take their time and make sure everything is perfect before we ever put humans on top of one of these rockets, NASA's most powerful rocket ever, and the second most powerful rocket after Starship in human history. So lots of testing underway. We are waiting to hear more updates from Artemis Launch Control there as they work these issues. They are still continuing through their fueling operations. So it's been nice to to have communication from their team on the half-hourly basis, and then intermediately there if there's something else to find out. We're expecting our next update from them to be in about 10 minutes, if not sooner, so we'll be listening into that. But take a moment, share out the broadcast, let people know that we're getting to the interesting part. We're getting to the part where they'll either be able to conduct the wet dress, or we're going to hear some updates on some of these other issues and what they will actually be able to do for it. Robbie says they tested the first shuttle with people, STS-1, wonder what changed. They did, but they also tested shuttle a number of other ways before. But with the rocket components, you are absolutely right. That is correct on what is happening. Douglas, the previous leak was in the tail service mast at the base of the rocket. Yes, that's where the quick disconnect is. It's part of that tail service mast for it. So we have heard a little bit about that. We haven't heard all that much. We are keeping an eye on Twitter and the media feeds that we can get from NASA on what may actually be occurring, see if we can get you guys any more information, and we'll be listening in to Launch Control there for more updates. Confirmation here that the liquid oxygen upper stage is now in stop flow. The team has discovered a hydrogen leak at the quick disconnect of the core for the core stage. Okay, here we go. Let's some clarification on what was said. They've discovered a quick disconnect, a hydrogen leak at the quick disconnect for the core stage and are undergoing review of the situation, but they have stopped filling liquid oxygen onto the upper stage because of this. So the ISPS loading, they detected that issue of the pressure, and that's what's happening there. NASA is evaluating, another tweet about evaluating the apparent leak in the core stage liquid hydrogen quick disconnect fitting. It's not clear yet if that was the same one that we had in the earlier fueling tests, but it is similar to what is occurring. And then, yeah, there was some sort of issue with liquid oxygen temps or pressures detected as well. So 2 issues they are currently working that we'll be waiting updates for. These are issues that could mean today would wrap up, but we're not saying that yet. We hope today still goes well, so stay with us here. But as always, if you're new, welcome. My name's Zach. I'm the founder and host here at the Launchpad. Here at TLP, we cover all launches, landings, dockings, testings, and exclusive interviews. We've got some interviews coming up with some of the Artemis 1 Orion teams. Make sure you stay tuned for those over the coming week or so. Those are exclusive one-on-ones with us. But we want to hear from you guys. Let us know in the chat, one, where you're watching from, and if you guys have questions, let us know in the chat. You can tag us at the Launchpad, and we will answer those live throughout today's broadcast. We will be staying live no matter what happens through today's testing window, as well as, after tanking, should something have to scrub for today, or if we can get through the wet dress rehearsal all the way, and then they do detanking. But Douglas, you are spot on. That is why they call it a rehearsal. We need to rehearse these before we go for launch. Keep in mind, NASA's not planning on launching this until end of August, early September at the earliest. That is the launch window they are currently targeting. If you want to see a full launch calendar, you can head on over to our Twitter. We've live tweeted the calendar there. We'll retweet it here in a moment, where we have the full launch calendar of availability for now up until June 2023. So lots of stuff of time to have there as we go through this time. But very interesting to see. Stratoblaster still on the couch with a couple of cats. That sounds a great way of doing it. Paul watching from the VAB. Paul, are you part of NASA and the team? Are you at the press site? Be great to connect with you either way on Twitter or Discord. Love to hear what it's like being there on the ground for today. And going from there. But yeah, if you guys have questions, send those in the chat. Take us at the Launchpad. We should be getting another update from NASA here in about 5 minutes, hopefully with some updates on these 2 issues they are working. We are still counting those clocks down to that built-in hold until we hear otherwise, and we'll go from there. Well, thank you for joining us, Paul. We appreciate having you joining us in the chat. If you have any insight, we'll always take it, but we're wishing this test well, and hopefully the weather looks good. The weather is nice and clear after the days of weather we've had. It looks like it's a really great day to conduct one of these tests, so hopefully these are some lighter issues that can be resolved and we can continue that countdown. But stay with us right here on the launch pad as we continue counting down through NASA's Artemis 1 wet dress rehearsal. Stay with us.
This is Kennedy Space Center in Florida at T-minus 1 hour and 35 minutes and counting. We've got a number of issues the team is working right now. I want to get you updated on a few of them. We mentioned that there is the bleed, the hydrogen bleed for the kickstart was halted when there was a leak detected at the quick disconnect for the core stage hydrogen. They're still evaluating that, still troubleshooting as well. The team, part of the team for the liquid hydrogen is working that. With regards to the upper stage of the liquid hydrogen tank for the ICPS, that is full, and they are currently working some tests over on that side, and that appears to be going well. With regards to the stop in liquid oxygen flow to the upper stage, the team there found that they exceeded pressure measurements on the downstage line of the upper stage skid. They now have a plan to go forward to reduce the pressure and get back into fill. The plan includes manually configuring valves to reduce the pressure on the upper stage. It will affect the core stage pressures, but the liquid oxygen team has assured the NASA test director that the plan's good and the plan's been signed off on, so they're putting that in work. And then we have a small grass fire that is burning near the hydrogen flare stack, where hydrogen that's bled off the core stage is burned. Too small. They appear small on the video feed. Patches of smoke. The grass, where the grass is burning towards a dirt road. So the belief by the launch team is that it will burn out once it gets to the dirt road, and it would be more risky to send a team out there to put it out than to just allow it to burn out. So that's a plan for that at the moment. So again, we got a number of issues that the team is working diligently on. We'll keep you updated. Again, that liquid hydrogen bleed kickstart has paused. This is where they condition the engines with liquid hydrogen. It's a lengthy bleed, runs for about 168 minutes. They get a high flow going through the engines. But that has been stopped while they evaluate a leak on the quick disconnect. It's on the tail service mast umbilical over on the east side, the hydrogen side of the core stage. And again, liquid oxygen looking to reestablish that flow after they get their troubleshooting plan going. We are, of course, tanking the Space Launch System today. Got the liquid oxygen tank in stable replenish. Got the liquid hydrogen tank, large one on the core stage. It's full. Have the liquid hydrogen on the upper stage full. And we came to a stop on the liquid hydrogen on the upper stage, or liquid oxygen on the upper stage. We'll keep monitoring the launch teams and their communications. For now, this is Artemis Launch Control. It's currently T-minus 1 hour and 7 minutes until the completion of the down to the simulated T0, and the completion of wet dress rehearsal for Artemis 1, the mission to test fly the Orion spacecraft around the moon. The launch team is working today as if it were launch day, but this is just a test to fill the tanks for the Space Launch System, all 4 of them with cryogenic propellants. A very complex operation that is underway and continues to move forward. I want to give you an update. We have some good news on the upper stage. The upper stage liquid oxygen is back in flow. The liquid oxygen team went back and did some additional troubleshooting, manually configuring a series of valves to decrease a pressure issue that they had on the downstage line of the upper stage skid. That's where, if you look there in the picture that you're seeing on your screen, that upper stage skid is where it feeds in that liquid hydrogen. It's second from the bottom. And the troubleshooting was successful. So good work there by the LOX team and getting that done. The other issue that they're currently working is the hydrogen leak in the core stage tail service mast umbilical bleed line quick disconnect. It's a mouthful. But essentially, they're trying to get a seal in a quick disconnect bleed line to reseat. They've got a troubleshooting plan, and what they're going to do, the liquid hydrogen team is going to warm that up back to ambient temperatures by manually configuring a series of valves, and then slowly chill it back down. The hope there is to get a seal on that quick disconnect to reseat and seal off that leak. Got a lot of smart people working on it, the Boeing propellant team, the SLS chief engineer, and the LOX team. So we'll continue to keep you updated on that. We're headed towards a simulated T0 at 2:48 p.m. Eastern Time. So again, liquid oxygen flowing to the upper stage tank. That's the only tank we have left to go. The other 3 are filled. And then they're working an issue with that quick disconnect line. That's it for now. This is Artemis Launch Control. This is Artemis Launch Control. I want to make a correction to the time that I listed for the T0. We are actually currently the clock is indicating that we should get there at 4:28 p.m. Eastern. Again, that is 4:28 p.m. Eastern Time. However, we're a little out of sync with the operation in terms of the tanking of the upper stage and the operations that are working to configure the rocket and the Orion spacecraft as if there was going to be a launch. So there's going to be some play there. There's a 30-minute hold that the team is working towards right now when it gets down to T-minus 10 minutes. And that is in about 50 minutes from now. Then they'll hold for a half hour, and see if we can get caught up here. It's not looking favorable that T-minus time will hold, but the team is continuing to work. And we'll pass along any updates to that T-clock as they become available. This is Artemis Launch Control.